Hello everyone, good to see you here. Welcome to the Biology and Sustainability by the Numbers course. I'm happy to see a full class. I would say that I'm aware that many people find it difficult to concentrate these days, and we will take that into account. And in that respect, I hope that you'll see this class as a constructive escapism or something to focus on and try to improve the world and do things that are positive using numbers. And for all those who are here but would need to go for reserve, or all those who are abroad and are taking the course online, or of course those who are on reserve and could not attend, we'll do everything possible to make sure that you can take the course, that you can finish it successfully. You'll see that much of the correspondence will be done on a personal level, and we'll be using the email of biologybythenumbers@gmail.com to do the correspondence. And basically to anyone who's here but would not be able to attend some of the future lectures because of the situation, or those who will be watching the recording and could not attend today, no problem at all. We'll make it that it works for you, and we could just correspond to basically build like a personalized suit on what could work in these days for each person. Okay? Good. I'm trying to make this course, I appreciate the fact that you came, even though some of those would also be available online. And I want to start with the question of what is the use of coming to a course in 2023 or soon in 2024? What comes out of the fact that we'll actually be doing it face-to-face rather than let the ChatGPT, replace me or you? So I want to start with that as a question. Why attend course in 2023, 2024? And that's the point that it becomes a bit, there's quiet, but every time there's quiet and I'm asking a question, I have all the time in the world. I'll wait. So I'm open to any suggestions. There's still seats, you're most welcome.
You get an immediate response instead of writing on the email and waiting for you to respond.
So, interaction. Immediate. More?
It's more immersive.
Immersive, I love this word. Yeah. Social. So it sort of like works on not only on our brain, but also being a social animal, also on other things.
GPT doesn't really work for quantitative questions if you ask it. So there's no really
ChatGPT not good for quantitative questions. Good, we'll talk more about it. Although who knows, maybe by the time we finish the course, there'll be a new version that will be better. But let's talk about it. I think it's a very relevant point.
Maybe to your opinions.
So you can hear others. Hi, welcome. More reasons, more thoughts? Okay, so if somebody does come with more thoughts also as we go along, feel free to share. I think that's all relevant, and really the kind of experience that I'll be hoping to give you in this course is supposed to be immersive and social and with interactions. And I think, and maybe we'll go beyond what ChatGPT has to offer in terms of the reasoning. And in order to make that sort of like it's all falling under the heading of, say, active learning, which is something that's easy to say but not so easy to do. So in order to do, I suggest you open your emails. You have the first question or first subject for discussion out there. So you can take your phones out and you're supposed to have something there. It relates to a dilemma that I have. Or maybe just as you open it up, maybe just one more thing to, so I was debating, given the situation today, whether it's better to give this course in the normal format, or maybe I should just record and have like a MOOC. You know what a MOOC is, somebody?
Massive online open.
Yeah, so MOOC is this, so people love acronyms. I don't like acronyms so much, but MOOC is massive online open course. And there are many such options today. There's like some big efforts, which I think are part of like the future and the hope of technology helping for education to make things such that, it could be reachable to many people, not only if you can pay a lot of money or if you have the privilege to come to a good institute like Weizmann, but you can do it, from everywhere, etc. And this has been a very strong trend. And in that spirit, one option would have been, instead of having this course with you here, is just to record once and for all the course as this interactive MOOC, and then maybe that's enough. And in order for me to handle that dilemma, whether I should do that or not, I decided to go and attend myself one or two such courses online in order to get an experience. And it was fun. I've learned a few things, etc. At the end of the year that I did it, I got an email thanking me for participating, and what you see in the email that we just forwarded to you. So we forwarded you the email that was forwarded to me. So who got to open the email and see the text there? Okay, who are still having a hard time finding it? Okay, so almost everybody got it. If not, just ask the person next to you. Okay, so you see the email that I got, and now the question is, what do you think? Any thoughts following on what you see in this?
Why not both?
What?
Why not both?
Why not both? Yeah, I agree. So sometimes you can do both. So that's true. But I want you to try and dig a bit more deeply in what I've just sent in terms of those of the content of that email.
The numbers.
The numbers.
I mean, why does it matter for you after finishing the course how many people all around finished it, or any course they offer, or problem sets? I mean, it's nice to write 117 million, almost 18 million problem solved, but what does it really mean, and why? I mean, what are they selling here? It feels like they are selling something to you, and I'm not sure what.
Okay, so you're saying at the end of the year, this head, I think it's like a professor that's in charge of all this beautiful MOOC effort, was, glorifying it by giving those numbers of tens of millions of problems being solved.
Yeah.
Right. What was the message of that?
You did something.
Yeah, so it's like really impressive, we did something amazing. Okay.
So if you look at the numbers, it means that each person that enrolled in the course tried to solve 4 problems and spent on it less than 2 minutes. So it's not really good.
What's your name?
Alex.
Alex. Did you follow on what Alex said? So let's okay, so that's something I want to do now. And that's like looking beyond. So I think, what's your name?
Sivan.
So Sivan is very right. I think this was sent in order to impress. So, numbers could be used in many ways. One of them is in order to impress. And I think you'll find that often it's being used as kind of like a decoration. People are giving the numbers and then they want to tell you, we did this, we did that. And the number is out there. But numbers could be much, much more powerful. They can be used in the sense that Alex says you try and infer something. For example, what Alex was inferring, that, okay, let's look at what were the numbers there. I think they say something about the enrollment. What was the enrollment? Anyone can refresh my memory?
33 million.
33 million.
600. No.
600 and 1 and
92.
92. Okay, and the other point that was mentioned was not just enrollment, but number of minutes.
Number of problems. Sample.
Okay, let's look at that later. Well, there was also number of minutes viewed.
Minutes of video watched.
229,405,000.
So 200 and what?
29.
29 million,
405,000
4 or 5,000,
and 155.
155. Very important. Okay, so these numbers look to me, this is minutes, and this is students. So these numbers, on the face of it, looks pretty impressive. Millions usually, the implication for most people is that millions is impressive. Okay, and another thing that usually looks impressive is like if you give it like the whole number, like not just saying 229 millions or 200 millions actually, you're saying the whole number. But then what Alex was saying is that you could say something more than that, because from this, if you think about it, you can infer that the number of minutes per student is roughly 200 million divided by 30 million, which is what?
Roughly 10.
About 10. Yes.
But I'm not sure that this is the right thing to look at, because enrollment doesn't mean finishing the course.
Yeah, so let's get to it in a minute. Okay, let's step by step. There's a lot to be said here. We could spend the whole hour. Maybe we will. But let's just take it step by step. Okay, so I'm with you in a minute. Okay, so one thing we could infer from this is that the average student spends 10 minutes overall. Now, we're already here for more than 10 minutes. And I don't think you feel it like you graduated from the course yet. So I think it shows something about the limitations of what's happening there. I think it also makes you rethink a bit about how impressive is what's happening and how deep is it, etc. And just to be clear, I think the overall direction of massive open online courses has a lot to offer the world. So I'm not against that. I'm just saying it's interesting that this email wasn't sent just to me. It was sent to these 33 million enrollments. So it's an email that was sent to a lot of people. I don't think I ever sent an email to more than 300 people. So this is an email that was sent, and I'm not really sure that the person that sent this email actually thought about what he's revealing about his life effort and something that so many people have invested so much time in. He was actually saying, we're like teaching each person like few minutes and then they're gone on average. It's on average, of course. And I think that also tells us, look, like to 30 million people, you reveal this secret that you don't even sure you want to say. I think it shows in a way like how the fact that numbers are a powerful tool, and actually the ability to do what Alex was just doing is not as common as you would expect or as the world should have, because actually it is something that could be relevant. Okay, so this is one thing you can infer. Anything else you can infer from the numbers there?
So courses are 1,300 and there are enrollments, so we can calculate how many students per course on average enrolled.
Good. So let's see. Okay, let's get to that in a minute. Anything else you want to try and infer from that?
Most courses are not from the best universities in the world.
Okay, we could now do the breakdown, which universities they're coming from. You mentioned something about the exercises before. So what do they say about exercises?
How long it took to work on each exercise?
Yeah, so how many exercises were done?
117 million.
Okay, 117 million. Okay, let's just make it 100 million. Okay, so now we understand that it's a very active learning thing, that like for every 2 minutes of, on average, for every 2 minutes of video, they gave one exercise. I have to say I have no problem with that. It depends. Now you need to look, maybe it's good to make sure that you're not just oozing out. It's very interactive, but it also shows something about, thing about exercises, as you'll see at the end of the course today. And for next week, you'll be getting an exercise. You'll have to spend quite some time in order to solve it, but it's part of the active learning, so I believe in it. But instead of giving you an exercise every 2 minutes, you're actually lucky. I'm giving you one exercise for every 2 hours. So you're in a good shape.
Ron, I'm sorry, but it's attempts. It's not exercises solved. It's attempts to solve exercise.
It's attempts to solve exercises, not exercises solved. Okay, how much, what do you think is the effect in terms of what factor?
15 maybe, 10, I don't know.
Okay, so that's, what's your name?
Oh,
Okay, so there's a good point here that, like, usually you'll see in most of the statements that I'll be giving in the course, there's things to be said. Like, what I'm saying, it's usually, the world is just complicated, and in order to, teach, we're taking something and we're simplifying it. Now, in order to decide how much emphasis to give on those extra points, this is all part of, the fact that we have a brain and we have to think, we have to put it in context and understand. So it's true that this is the number of maybe exercises attempted and not the exercises solved. I think the success, the involvement of something is higher than 50%. Also, in order to continue, you usually need to enter to access. So I think it's like 80%, 90%, 90, whatever. But for most of the things that you're saying, I don't care if it's like 2 minutes or 4 minutes or 3 minutes or 5 minutes. It's the same point. So really, as you see, many of the things I'll say, if you have a correction that, or another comment that would give less than a factor of 2, you're probably right. But for our cases, it doesn't matter. By the way, that's very different for, like if you have a comment on the salary of a PhD student at Weizmann that would do a factor of 2, I think it's a relevant comment, right? Like you care a lot if it doubles your salary or makes it half. So there it's important. For the kind of analysis that we'll be doing, often it's not important. Okay? Good. So we have the number of exercises. We could see what we could infer from that. Okay. The next point was about, there was something to be inferred about the number of, what were you saying? The number of courses?
And the number of enrollments.
Okay. So what is the number of courses?
1,300.
Okay, so I think that's very relevant because that goes back to my dilemma. You remember my dilemma? I was thinking, and hearing from people, like you have this dream. Now, I'm giving this course and I'm really happy that there's good attendance here today. It's one of the popular courses at Weizmann, but it could have been much better, right? I want to send the message to the whole world. And then these platforms, they offer you the promise that you'll give a good course. And then who knows, millions of people around the world will be watching it, Far East, Latin America, all over the place, who knows. And this is also at the heart of it, right? Because you might have heard like the course of linear algebra being taught online. There's like or the AI course in Stanford. There's like tens of thousands of students, which is the dream of every good teacher. And this sort of supports it, right? Because if you take 30 million and you divide it by 1,300, it means that on average in every course, how many enrollments do you have? So number of enrollments per number of courses. So that's roughly what? We have 30 million divided by this, so that's about 20,000 students per course. You following me? Okay, so this is the dream, right? This is this is like really what creates also the notion or the myth that like, yeah, it's fantastic. You'll have a course there and you'll have so many people watching it. Yeah.
We can also know how many problems there were per course, and then we can
try to figure out how many students actually tried to figure out every problem. And when
Yeah.
we get to this number, it's very low number. So it's like if you only had 4 students who actually try to solve problems, what does that mean?
Good. Okay. So we could you're saying we could connect this. On the one hand, we have this very large number of students per course. But now let's say either with the number of this or let's say with this number, we could now try to turn that from like this very big number into the number of, let's say, call it effective students, right? Okay, so let's think, so in order to do that, we need to think, okay, how many such, this is student of MOOC. I want to convert it now from a student of MOOC to a normal student.
So we can like take the number of problems and divide it by the number of courses.
Okay, so we could do it through the number of problems, but I would just want to do it with time. Time is a very intuitive unit and I think very useful. So let's turn that into thinking how many, like a normal student, what is the time that they will be watching, that they'll be participating in the course. Okay, so, okay, we could, I want to keep that, let's do it here. Okay. Let's call it normal student. So what is the number of minutes that you'll be expecting for a normal student?
10 minutes.
So I would say there's about, let's say 10 lectures per course. And they're watching each lecture is about 100 minutes per lecture. So this is about 1,000 minutes. Sounds reasonable? Okay. So now a normal student is 1,000 minutes. The student of a MOOC is 10 minutes. So I have a correspondence that like every 100 students in a MOOC is like 1 student in a real course, in a normal course in terms of time investment.
Sorry, you need to see the distribution. If you have a lot of them that just enrolled and
Okay, let's get to,
out.
I agree, let's get to distributions in a minute. Okay, this is a valid point, but I want to get into it in a minute. Okay, so this 20,000 is converted under that ratio of 100 to 1. This becomes now 200 students per course. Okay, so I think now we're in a better position to help me. Okay, like when I was thinking about the dilemma, do I want to give this or not? Before I got into much more deep details of, distributions, other things, just from this email, I already understand that it's not that I'm going to give a course and now there's like millions of people around the world who's going to enjoy it. Not even tens of thousands. It's something equivalent in some way maybe to 200 students. Now, those 200 students, many of them are going to have like an attention deficit, right? Because like on average, they'll be watching just for 10 minutes. So it's not the best students that, that I'm hoping. But now, okay, now we get into the whole issue of distribution. So some of them will just be watching like 1 minute and then, or maybe they just signed up and they didn't even start. And some of them watched just 1 lecture and said, okay, I had enough. Maybe like some of you will decide after today. And some of them did the whole thing.
This is for the 20,000. The 200 students are like good students who do the full course. This is what we calculate.
Okay, so there's a good point. What's your name? So Yotam is saying, yeah, we calculate for good students, like those who do the whole thing. So we did something which is a hybrid, right? Like we took all the minutes. Some of them are like good students that did the whole thing. Some of them are those that like just a tiny bit, etc. And we lumped the minutes all together, apples and oranges together. And we did on average. So this is like, if you like, all together I'll be getting 200 students, like in these small bits or big bits or whatever. Within it, I don't know. It depends. It's probably, I would have like 50 students that would do the whole thing, 500 students that would do like 1 lecture, and another 15,000 that would just open it up and watch it for a tiny bit. Okay, and altogether it's effectively like these 200 students. Okay, so I guess that's much of what I wanted to tell you about this specific point. And I think it shows, in terms of this, it shows, both the promise, you can reach millions of people, but also the fact that today it's not really at, what people were necessarily expecting. I will tell you, to make a course, you have to spend a lot of time. Like, you have to prepare it like really perfectly. You have to have, a good, you have to invest in it a lot. And now whether it's worth it or not, you could do the analysis and learn more. Okay? There's another thing with the distribution. One was about distribution of minutes watched. Did you have a different comment about the distribution? Because there's another interesting point here about distributions.
Enrollments and finishes. Who
What?
enrolls and who finishes the course.
Okay, there's something about who starts and who finishes. That's the one point that we did discuss it. There's another distribution hidden here. So remember, there's like these 1,300 courses, right?
Which are more popular or which are less popular?
Yeah, so what's happened? How is the time invested? How is it distributed among those 1,300 courses? When you're coming to teach a course, you're probably thinking about, my course would be as popular as the introduction to artificial intelligence at Stanford. But that's probably at the very end of the distribution. And they have these, different types of distribution. There's usually like a big tail, blah, blah, blah. But usually there'll be like some very successful courses. And then the vast majority would actually be not even close to 200. Because you'll have a few that effectively will have like thousands, but all the rest will just have, very, very few. That's how any distribution almost usually behaves. And that's probably also holds here. So that's another thing to take into account. When we were taking average, in a way, we were kind of a bit optimistic. Like we weren't necessarily, because you were expecting that it behaves such that you will be just enjoying as everybody. Whereas usually the very popular courses, already somebody gave them. Now when you're joining and you won't necessarily be at the best place in the distribution. Okay, more thoughts and comments about this? Okay, so the reason I did this wasn't about my dilemma, even though because I decided about the dilemma a while back. I think that was like talking about numbers and how they could be or could not be useful. How actually rare is it today that people would actually take numbers, not in the sense that was mentioned here about things being impressive, but about something that you can get insight from. And my almost promise to you is that if you do the exercise, you keep with me, we continue working, especially with the help of Lior Greenspoon here, who's the teaching fellow of the course, and together with Sam, who's also the teaching fellow in the course and will be coming from the UK very soon. You'll be able to be in that very small part of the distribution. It uses numbers in order to teach you something deep and new. And it's like a superpower. At least that's what I experience in life. It like really opens many hidden doors and enables you to do all sorts of hocus pocus that other people could not do. So that's my promise to you. And in the way that we'll be doing it, we'll try to do it in this way. Okay, that I hope will be interactive and immersive and social, etc. And some of the things that I'll ask you to participate or to do in the exercises are based on that. I hope you'll collaborate with that. Okay, good. So that's the plan. There's one other thing I was thinking about that still relates to that to those kind of analysis. I'm sitting in all sorts of boards and organizations, etc., that are working hard on trying to teach, say, science to the public in efforts that are not unlike there's MOOCs, but there's also other ways in order to try to teach the public. For example, here we have this amazing thing of the Davidson Institute. Some of you might be participating in trying to teach in that way, etc. And usually when you're trying to do analysis of those things and what they're offering, often you also see like big numbers of number of students, number of courses, number of schools, number of teachers, all sorts of that. And I was trying to see if I could also try to give myself a sense of like the impact or the cost benefit of such things, and maybe even like compare between, say you want to compare between such a massive open online course and let's say just, normal teaching of a teacher. Okay, so what did we get here, for example? We said that everyone giving this course will have on the average about 200 full-time students, each one participating in 1,000 minutes. Okay, so somebody who created a MOOC, which I'm telling you it's a lot of work and sometimes you still need to do something operational there, they're getting every year how many minutes of engagement of students' time?
Can you ask me?
Okay, so I'm saying somebody who created such a course, on average, how much time of students he'll be winning their attention? Okay, let's talk in units of minutes of attention.
100,000.
Yeah, so it's like the number of students times the minutes of attention. So you could say MOOC, sorry for that, MOOC course is roughly 200K minutes of attention per year. Does that make sense?
Per semester.
Per semester, yeah, let's say it's once a year. Okay, it's true. Per course, per something. Okay. Is that a lot or little? So we did something and gave you some comparison, but I'm looking for a yardstick that would enable me to, because numbers, especially big numbers, are best done if you have a good context. If you can put it in comparison to a non-number. Okay, like usually numbers don't mean much, by themselves. It's numbers versus other numbers.
You can see how much days people like.
The ratio per course of the number of people, how much?
Right. Okay. So there's several ideas here. I want to show you one thing I'm playing around with these days that that I think would be a relevant yardstick, and that's the teacher attention yardstick for comparison. Okay, so what is that? That's thinking about, okay, how much time of attention does a teacher get from teaching during a year, let's say in high school. Okay, if you want, it's kind of like there's these units. I don't know if somebody here comes from that area, but there's something called FTE in management. Somebody heard about FTE? Nobody. Okay, it's great how our students, body of students doesn't know anything about the business world at all, not connected to anything in the real world. So FTE is like, I think, full-time employment. Like if you're working somewhere and you have many, you want to know how many people are working in your place. But some people are not working 100%. Some people are working 10%, 5%, 50%. So the way to aggregate it is not unlike what we did. You say how much is it like of full-time employment, of like full-time working in your place. Okay, so if there's 10 people working half-time, it's like 5 people. Okay, so it's kind of like this. But because you don't know it, it doesn't mean to you anything, so it doesn't matter. Okay, so what's the teacher attention yardstick? I want to make it the number of minutes of students listening per year. Okay, that's what I would like to do. Now I want to calculate how much that is. Okay, hi. Yes, what was the comment?
How much time does the MOOC courses are online? Because it doesn't say these numbers for 1 year. It says overall. So it's not. Why is it per year?
Okay, good. So I get it. Okay, so you're asking about the time basis here. So first of all, I'll say all of this that we did, that was like end of the year. So this was like on a yearly basis. This was like number of enrollments, number of minutes, number of exercises per year. For the simplicity, let's imagine now that every course, etc., is done once a year. It's true it might be done twice a year, but as I told you, factor of 2, I don't care so much. But also we could talk about what the implications. But for now, let's talk about a yearly thing. Okay, which is also, again, what we did was for per year. I don't know, maybe inside it was given several times per year. I don't mind so much. It's like an effective one course. Okay, back to this.
Question.
Yeah.
This yardstick that you defined, how is it different for the calculation that you did there and with the green marker? Or is it not different?
What's different?
We counted the minutes that people listen to the MOOC course. The
So
200,000 minutes. Is it the same or different?
No, so it's the same.
Yeah, okay.
It's the same. It's 200,000 minutes on average per course, which again sounds, I don't know, usually it sounds pretty impressive to people. Why? Because it's 200,000. When we think about 200,000, that's usually a lot. Let's say in your bank account. Okay, but let's talk about this teacher attention yardstick. I want to know the number, just 1 second, number of minutes watched by, of attention that a teacher gets per year. Okay, can you help me do the, not comments now, help me do the calculation, yeah.
You have that the normal course, one student has 1,000 minutes of attention span a year, basically. So you just multiply by the number of average number of students per, I don't know, university course, say 50 here or something like that, and you get 50,000 minutes.
Okay. So let's do it more slowly now. Okay, does that usually like, so you can do it quickly, let's do it slowly, okay? And let's take, you don't necessarily know, how much burden of teaching there is, or, at Weizmann. So let's do it on a high school, something that we all passed through and successfully, I think. And so we know, we have some intuition on that. So we could take the number of hours per week, multiplied by the number of weeks per year, multiply that by the number of students per class, multiply that by the number of minutes per class. Okay? Often, I usually like to jump into the numbers, but I find that usually it helps when you want to communicate with people to just first, talk about the logic and only then plug the numbers. Okay, let's plug the numbers. How many hours per week? So it depends. That's another thing you'll see. Often when you talk with people and you ask them something, they tell you it depends. And that's true, but that's not so helpful usually. Every time people answer you depends, you tell them, yeah, but is it like roughly, 10 or 100 or 1,000 or 1,000,000? Okay, so number of hours per week.
For a teacher, a single teacher?
A single teacher.
Order of one. Maybe
What?
2, 3.
No, I'm talking about a teacher teaching in high school. So I think it's so 20, 40.
Jobs, so probably 20 is for like teaching.
Okay, so somewhere between we get 20 and 40. Let's make it 30. And I like to write it this way. It's like few tens. Okay, let's talk about, because I don't know if it's 2 or 4 or 3. So let's call it F would be few. Okay, few tens. If I just want to be even like look sophisticated, I can write it this way, F0. Okay, it's like the digit. It's like a new digit that I invented. F is kind of like 3. Okay, anyway, 2 and 5 or something like that. Okay, by the way, I didn't invent it. There's this, there's this very smart guy, Sanju, I forgot his family name, who teaches a course at MIT called Street Fighting Mathematics. Okay, which is kind of like, if they ask you a question in math, but in the middle of being, doing street fighting, and you want to give an answer like really quick, so you have to find a way to do it, and it's amazing. It's also available online freely. You can look at that, very nice. And in a way, our course is like the same thing, but just not for mathematics, but using numbers for biology and sustainability, and maybe also teaching. Okay, good. So let's make progress here. So we have a few tens of minutes of hours per week, right? How many weeks per year does the teacher teach?
Few tens.
40.
Yeah, a few tens. Okay, how many students are in a class in high school? Few tens. How many minutes are in a class? Few tens. Okay, well done. So we have about few tens to the fourth. How much is that? So I didn't tell you, there's a nice trick. F times F equals? Equals 10, right? Okay, like few times few, it's about 10. Because almost all the answers to my questions are 10. But just the question is 10 to the what? Okay, so sometimes you need to do the few. So few times few is 10. Okay, so we have this. So this is equal to how much? This to the fourth would be 10 to the fourth. And the few times few is 10. And another few times few is 10. So altogether I have 10. So I had 10 to the 4. And then we had the f to the 4, which was equal to 10 to the 2. So altogether it's 10 to the 6. 10 to the 6 what? So this yardstick is equal to 1 million minutes of student attention.
It doesn't have units of time, what you wrote.
It will. What you mean from looking at the units here?
Yeah.
So let's see. So we had, we had weeks. Oh, but did you understand the comment, first of all? It's a nice comment. Usually physicists like to do this comment, that they're looking at the units and it doesn't fit. I really like these things. But then usually I find why. Okay, so let's make it a different color so it's easy to follow. So we had week and weeks. What's happening here? So it's going to be, okay, hours and class is like, it should have been like hour. Right, it's like the number of minutes in an hour of teaching. Good, so now what we have, so it's student minutes per year, class. Okay, I have to think why we have, but I think, like I'm not wrong, we have to think about how the units are defined so it works properly. Yes, yeah, you can think about it as teacher. Yeah, that's true, so it's like, yeah, it's like saying, what we want the number of students minutes per year per teacher, right? Okay, so instead of, somewhere here it's better to call it teacher rather than class. Yeah, how many students that the teacher has? Yeah.
I wanted to understand if f squared is 10 and f to the power 4 is 100. What is f to the power 3? I didn't really get the logic of how you do this.
So f to the power of 3 would be like, roughly 30.
What? How did you
Okay.
get there?
Okay, so we could talk about it. It's not, I just want to give a break soon. So we could talk about it in the break. Okay? Good. Okay, so what did I want to say? I want to say, using that yardstick of 1 million minutes, that now sheds, for me, like light, for example, on these 200,000 minutes of this average MOOC, is that it means that, who has a parent here that's a teacher? Like your mother or father? Quite a few. Okay, so, my mother is a teacher. I think, we should give them respect. They were like giving 5 MOOCs. 5 MOOCs, not one MOOC. 5 MOOCs every year for like, decades. So like, you can, it gives some perspective. So we had this 1 million. This 1 million gives us context to this 200,000. It's not exactly the same. And also time spent in class, is it better or worse than the time spent watching a MOOC? It depends. There's advantages and disadvantages to each. On the one hand, usually it's more immersive to be in a class. On the other hand, you have all sorts of distractions and you're actually doing something else, not necessarily focusing on the course. So it has different, so it's really apples and oranges, but I think it's still can tell you something if you know the weight of all the apples and the weight of all the oranges. It's better than just knowing there's like a 200,000 kilograms of apples and you don't know whether it's a lot or little. If you know how much, is the weight of all the apricots, then it gives you some sense of scale in relation to that. Okay? There's actually a lot more we could infer from such things, but we came to talk about biology by the numbers to a large extent. So before we go to the real break, let's give you something to think about. Okay, so let's take a concrete question. How many protein molecules, which is simply known as proteins, are in an E. coli cell? So just to be clear, what is the question? I want to know how many proteins, but not the number of like genes that turn into. I want to know like the real number of like if I was going and counting each one. So if something has this number of copies, I'm counting all the copies and then all the copies of the other protein. All together, I'm asking how many proteins are in a microbial cell. And I'm talking about E. coli. Why? Just because it's just like the pet of all molecular biologists. It's something very common we study, but in a way you can think about any other bacteria that you like.
Can you give relevant data?
Yeah, so it's really hard to answer such a question like out of the blue. So I usually like to give options. Okay, so let's make it into a multiple answer question. Is it about 10 to the 4 or to 10 to the 5? Or 10 to the 5? No, excuse me. 10 to the 6 to 10 to the 7? Or is it 10 to the 8 to 10 to the 9? Or is it 10 to the 10 to 10 to the 11? Or is it more?
And like numbers like volume of E. coli, volume of...
We'll get to it. We'll get to it. We'll get to it. In the meantime, I just want to get like either your intuition or your thoughts, if I know. Because one other thing we'll try to achieve in this course is to be proficient at making inferences with numbers. This one type of superpower that we want you to have. The other superpower is you want us to have intuition for numbers, but much stronger intuition than usual. Like that you can also understand things about, for example, number of proteins inside the cell, which is like a superpower that very few people have, because it's something not close. We don't have intuition usually for the inner workings of a cell. It's like a microscopic thing, and this is a microscopic within the microscopic. So like nobody has a good intuition for that. I hope that by the end of the course you'll have a better intuition for that. Okay, so we didn't. Yeah, we'll get to how we do it soon. But just before, to give you time to go to the break, let's just we didn't have an election in Israel for a very long time, so it's good to keep preparedness. So let's do a quick vote. Who's voting for 10 to the 4 to 10 to the 5? Option A. 1, 2.
Can you just say what like the size of
3.
protein about?
We'll get to it in the second hour. Okay, so we have about 4 people. Okay, so we have few people. Okay, who's voting for 10 to the 6 to 10 to the 7? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10-ish. Who's voting for 10 to the 8 to 10 to the 9? Okay, there are few 10s. Who's voting 10 to the 10 to 10 to the 11? Few people. Who's voting for more? 1. 10 to the 0. Okay, so my challenge for you, we'll take like a 10 minutes break. My challenge for you is, either to infer the result. And as you see, I'm not looking for a very accurate number, like 5 to 6 point something. I'll give you, tell me within a factor of 100. Okay, so I think it's a fair game, even if you don't know exactly the size of this or like how many amino acids is in the average protein. But if you can't do that, which, I expect, most of you can't give the answer, my thought, just try to do what's known as divide and conquer. What is divide and conquer? It's like to take a big problem, a big challenge, and to just say, conceptually, I would try to infer this, and then I can infer that, and from this and that I can do this, and therefore I will know that. Okay, just try to do it kind of like what I did for here. I need to do this, times this, times this, times this, and then I will have the answer. Okay, so try to just create that logic. And even if you can't do that, just try. Okay, because actually learning is happening much, much more potently, much stronger if you have a horse in the race. If I'm just giving you a question, you say, it's an interesting question. Okay, I'll come and listen to the answer. You will learn much less than if I'll tell you, it's an interesting question. I'll try to do something. I have a horse in the race. And now what I'll be teaching you would get into much better context afterwards. Okay, so we'll take a 10 minutes break. We'll reconvene after you try that. And we'll also take the opportunity to see some of the safe rooms around here. So, we are reconvening. Just so everybody is on the same page, you might have seen, if there's again an alarm, a real one this time, as you exit here, there's like a sign of like the safe place, and there you can get inside. On the left or on the right, there's actually quite a lot of space on the right, so it should be okay. I would ask everybody that they have this to try and put it either on mute or close it or whatever. If there will be like a real siren, we'll hear it through the loudspeakers here, and there will be no way for confusion. Good. Okay, so last time we met, 10 minutes ago, you had the challenge of how many proteins molecules are inside the bacterial cell. And we tried to talk about just giving us like even just like a blueprint of how you would approach it in this divide and conquer approach. Anyone wants to suggest how they would try to do it?
By volumes. The size of cell would be a micrometer, and the size of a...
Okay, good. Let's start there. Okay, so let's just try it, and we'll put the numbers inside in a minute. But one way to approach it is to say, okay, I'll start with the size of bacteria. From the size of bacteria, I can tell the volume. From the volume, I can tell the weight. So we'll need the weight in a minute. We could do it in different ways, but so you want to do it just on the volume?
Yeah.
Okay, good. So I'm just writing here. We could talk later. Volume versus mass. Okay, so good. There's different approaches. We could talk about them in a bit later. Okay, this would be the weight, and then and this is weight of cell, right? Okay, what do we do afterwards? After we have the weight of the cell, so I'd like to go here from there to get to the weight of all proteins inside the cell. This is one thing I'll get here that's also already pretty far. But now I would also want to know the weight of one protein. And then I can merge this together with that and get to the number of proteins per cell. Okay? But now I want to track back in order to know the weight of one protein. How would I know that? I would also need to solve this, so I'm suggesting I'll know the weight of the building blocks of proteins. What are the building blocks of proteins? Amino acids. So I'd like to know the weight of an amino acid. And what is the other thing I need to know? Number of amino acids per protein. And then I'll merge this together with that. I'll get the weight of one protein with the weight of all proteins, number of proteins per cell. Okay, the logic of what I'm suggesting is clear?
Yeah.
Good. So we'll head to that. But you had a different way, right?
Yeah.
And what was it roughly? You also had this to that. And then
Yes.
what?
And then the volume of a protein, approximately. And then the fraction of proteins in a cell. And that's it.
Fantastic. Okay, so it's very similar to this. Also, with the going here is like the fraction of proteins inside the cell. But instead of doing it going through weight, you did it directly from the volume.
Yeah.
Okay, so just because I'm curious, what did you take for the volume of a protein?
So I thought that the diameter of an average protein would be a few nanometers, because you can see protein by light microscopy, so a few nanometers, and then and a fraction of proteins to be 10%.
Okay, we'll get to that, but just this thing. So a few nanometers for the protein. Okay, so just to be clear, so it's really two similar but still quite different ways to approach it. Not quite different, doesn't matter. Two parallel ways to do it, somewhat overlapping. And now the question is, what are the advantages or disadvantages? So in order to do this, you need to know something about the volume of a protein. And that's not so easy from different things. One, we don't have a good intuition but also when you're saying few nanometers, you then have to cube it in order to get the volume. And then you could have more than twofold, uncertainty. And with this, I think it has some advantages. We'll see. We'll go through it in a minute. Okay, good. What I need now is space. Okay, so let's see how I'm making more space. Let's get rid of this. Yeah, maybe we'll do it here. Let's see if that works. Okay, I did forget to say before, you'll sometimes get like this knee-jerk reaction when I'm saying, 5 is like, instead of 5, I'm putting it as a 10. It's very normal. You're okay. Live with it. You'll see during the course, when it's not that I don't know the difference. It depends really on how accurate you want your answer to be. If you just want to know order of magnitude, that's fine. If you want to know much better, it's not fine. If you just want to know within a factor of 100, then definitely it's fine. Okay. And then the other thing to mention, everything that I'm doing here, some of you or like people from backgrounds might know is like Fermi problems. It's like this order of magnitude estimates. This super smart physicist by the name of Enrico Fermi got the Nobel Prize, etc. He would do these sort of like questions and things a lot for all sorts of different things. Famous thing is how many piano tuners are in Chicago, and he could just derive it, just like that. And actually, you'll be able to do that yourself, and we'll talk in the end. That's kind of also your final exercise would be to do something like that by the end of the course. So you'll be small Enrico Fermis by that time. Okay, and we also had the break. Good, and we talked about, this was the divide and conquer. Good. Okay, so let's start at the beginning. Size of a bacterium, of E. coli. Anybody knows anything about that?
Diameter is micrometer?
Yeah, so a good scale for a bacterium. So here's the bacterium. And it's about 1 micrometer, which is how much?
10 to the minus 6.
10 to the minus 6 meters. Okay, and this is good enough for what we need to know. It's actually also pretty good. This is not unlike how a bacterium looks. It's a bit different, but it's true that like the relevant scale is 1 micrometer. And it's also nice that you see some of these numbers you wouldn't know, but it's much easier to know that the rough size of a bacterium is 1 micrometer than needing to know, thousands of different facts. What you'll see is that like with just a few numbers on the order of like how much? 10, with like about 10 numbers that you know in biology, or maybe few tens, you can infer, thousands and thousands of different things which is very, very, I think, elegant. So it's not like you can do it out of thin air without knowing anything. You do need to know that like 1 micron is roughly this size. Okay, so if I know this is 1 micron, what's the volume?
You have to take about half of this, and then the volume is pi times the radius squared.
Okay, so there's somebody who still remembers geometry. But I would just say, I don't remember it necessarily, I would just say it's a 10 to the minus 6 meter cubed. Okay, so for my purposes, it doesn't matter if it's a sphere and there's 3/4 pi, blah, 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 blah. I could just say it's just like a cube of 1 micrometer by 1 micrometer by 1 micrometer.
But this is order of magnitude, because if you take half and cube it, then it's like
Yeah, you're right, it's order of magnitude, but if you remember, I was giving you even more than order. I had slack of like 100-fold. So I'm fine with order of magnitude. You understand our little fight here? Okay, so we're fine with that. Okay, so we got very far. We already have this, which is equal to 10 to the what? 10 to the minus 18 meter cube. So far, so good. Okay, so if I know the volume of a cell, now I want to know the weight of a cell. So how do I go from meter cubed into something that has units of weight? Okay, so I need to go through the density, right? What's the density?
It's mostly water, so it's 1 gram per milliliter.
Yeah, so the density is 1 for our purposes. It's actually 1.1 roughly, but who cares? On 10%, so it's about 1, which means that it's, and it makes sense because most of it is water. So 10 to the minus 18 meter cubed would be translated into 10 to the minus 18. How much does a meter cubed weigh?
1,000 kilos.
Yeah, 1,000 kilos or 1 ton. Anybody has a question about that? We're fine? Okay. So about 10 to the minus 18 ton, which is about 10 to the how much kilogram? Yeah, minus 15 kilogram, or 10 to the minus 12 grams. Okay? Why am I changing the units? I want to go and arrive in the end. You understand what I need to do in the end, right? I need to go to the number of proteins. Okay? So I have to go down to the things that are how things are measured microscopically. Okay? Now I didn't ever see anybody talking about the cells and components of cells in units of tons. Okay, maybe in drug production. I don't think people do it that way. They actually usually also don't do it with grams. What units they're usually using? For weight of things in components of biology? Daltons, right? Yeah, so I'm trying to push us to go towards Daltons, which is this unit of, a Dalton is like the weight of, like a hydrogen atom, or like, a proton and neutron, or like, actually I think the definition of a Dalton is 1/12 of the weight of a carbon atom. Okay, which, relates to chemistry and biology and all that. And I need to push myself from going this to that. It's actually moving, and you'll see that's one unifying thing that happens in many other things we'll do in the course. In cell biology, you need to go from the things in the macroscopic world, like tons, into the microscopic world. That is number of proteins inside the cell and Daltons and things like that. So I need to push myself there. Okay, so I got to, and that's why I moved from ton to grams, because grams are related to Daltons. Like it would take me to it's like the gateway to the microscopic world. Okay? Anybody, who heard about Dalton? Something vaguely familiar? Okay, almost everybody, maybe everybody. If not, Google it. Okay, so now I need to do this jump from the macroscopic to the microscopic world, from grams to, I want to have here Daltons. How do I do this? How do I go from 10 to the minus 12 grams to some number of Daltons?
multiply 10 to the minus 12 by how many
Yes, exactly. So how many Daltons are in a gram? Anybody remembers that from your undergraduate? What?
In a gram of what?
In a gram of whatever.
Yeah, 1 mole.
1 mole. Exactly. So there's this 1 mole thing, which is the thing that turns from grams into Daltons. I see people smiling, getting like it's like old friends that came to visit after a long time. Okay, and how much? And you might even remember there's like this nice n. And I hear 6 to the 6 something, 6 what? 6.23, right? Okay, so good. 6. Usually it's interesting because we usually remember the 6, but we don't remember the 23, which is really not like the 6 doesn't help you so much. The 23 is more important. You know what? I don't like 6. I don't think in the course we'll have 6 at all. Let's just make it 10 to the 24. Okay? How is that useful? It means that 10 to the minus 12 grams, in order to turn it into Daltons, I need to multiply by 10 to the 24. Which will be how much?
10.
Yeah, so we're staying with 12. Now it's 6. It's 10 to the 12 Daltons. Okay, you might even say, we've been spending so much time, Ron moves like nothing really happened. But actually we achieved a lot, because from now we really got into the into the world of the cell. From here we could really infer things for the question for what we want. How do we do that? So we actually got from here into here. So we have this 10 to the 12 Daltons. What's the weight of all the proteins? So so the question is, in a way, what is the fraction, as was mentioned here before, what's the fraction of proteins inside the cell? I'll help you. The answer is 10.
Okay. Because most of it is water and the rest 30% is the mass. So let's assume 10% of what is.
Yes, so about, let's say, so we know that about 70% or 2/3 is water. So I'm left with 30% for all the other things in the cell. Okay, what do we have in the cell? We have protein plus sugars plus nucleic something plus lipids. So how much is proteins? So proteins is about 10%. 10 to the minus 1. Okay, roughly, order of magnitude. I'm not saying it's exactly that way, even though it's actually not very far. But if it's 15% rather than 10%, it's not so important. Okay, so we have that. So that means that I can go from 10 to the 12 Daltons to 10 to the 11 Daltons of proteins. Okay, now we need to do this arm. Okay, for that we need to we solve this. We talked about this. We need to know the weight of a protein. For the weight of a protein, I want to know the weight of an amino acid and the number of amino acids per protein. Okay, how do we do that? What's the weight of an amino acid?
110 Daltons in average.
Okay, what if you don't know that?
Few hundred. No, few tens.
Okay, so on that, I want to go even more deeply. I want to say, try to infer that. I want to remind myself, what is an amino acid? Or, I'm a professor of biochemistry, so I should know. So amino acid. But I didn't ever learn it properly, but I do know to read. Okay, so there's like amino and acid. Okay, amino, I remember something with an N, like a nitrogen. And the acid, I think there's something like with a carbon and there's like some oxygen somewhere there. And there's also something else, some magical thing, usually R. There's like, there's something else here, I don't remember exactly what. Okay, what's the weight of this? We could see, so this is roughly, this is like 10 Daltons. This is also about 10 Daltons. This is heavier, this is like 20 Daltons. Another 20 Daltons. And this depends. But altogether, and I forgot some hydrogens, and there's a bit more here, I think you agree with me that it's 110. Okay, it's 10 to the 2 Daltons. Like, what did we say? Like, I think from that, we know that it's not few tens. It's more than a few tens. And we could say, unless something is super crazy with the R, it's not few hundreds. So in these jumps that I allow myself, things are either like 10 or few tens or 100 or few hundreds or 1,000. I actually know the answer. In this case, it's about 100. Okay, so I know enough biochemistry to know this. Number of amino acids per protein.
A few hundreds maybe.
Yeah, so that actually I don't have a smart way to tell you, why it has to be this, but it's true, it's few hundreds. Okay. Okay, so the weight of one protein is how much? It's few times 10 to the 2, 10 to the 4 Dalton. Okay? Good. So now all I need to do here is to divide these two numbers. So it's about 10 to the 11 divided by few times 10 to the 4. Now you see we also have the 1 over f, which is kind of funny. We could just take a 10 out, and then 10 divided by f is f. So it's few times 10 to the 11. We just have, I'm writing it as like f times 10 to the 10, if you like. Okay, and then f with the f is f, 10 to the 10, 10 to the 4, 10 to the 6. So a few millions. Okay, a few millions in an E. coli cell or any other bacterial cell that you like. And this should be some sort of like a catharsis moment in the lecture. So we know the answer. The answer is, this. Who are the 10 people that, well done? But I think the people that should be happier are the other ones. Because, you've learned something new, 100-fold new or something like that, like seriously new. And you can see how, we didn't need to know a few things, but we got from knowing few things that kind of everybody is expected to know if you're a student of biology, into something that I bet you can just, I don't know in which lab you're doing your PhD or something, go and ask your advisor how many proteins are in the cell, and I want to see, they'll say it depends. But you now know something that very few people in biology know, and as you'll see in the future lectures, it's very strong. Like you can do many things with that. And not only for bacterial cell, we'll be talking how to do it for different cells, etc. You did all the heavy lifting. From here it's super simple because you could just scale. If you want to know for a HeLa cell, for a mammalian, for a mouse, for this, for that, everything is simple once you're here. Okay, and just so generally, let's pass what we have here. We had this taking a problem, breaking it down with this divide and conquer thing. Use few things in order to infer the few numbers, and then just be diligent at moving things and try to move in terms of the units towards what you're trying to solve in the end. Okay, and you'll see that like there's like in trying to approach some things, as many other things as well, there's like sometimes a fear of math. And so maybe when you register to this course, maybe because your friends didn't register for the course because I don't like math or something like that. But you'll see that the kind of math that you need to know throughout the course is not any different than what we did here. It's kind of like you need to know how to multiply, how to add. You need to be okay with 10 to the something. I think that's it. Okay, that's like the kind of math you need to know. Supposedly, like somewhere between junior high school and the start of high school. That's it. I don't think we'll need to exponentiate, or definitely you don't need to do like smart integrals or whatever. But as you'll see, you can infer from that things that usually, like even like the most quantitative people around. Okay, so if you're worried about math, don't be worried. And if you know people did not come because of that, tell them they could come. The other thing that like it's worthwhile, so this is one kind of syndrome, the math syndrome. There's another kind of syndrome known as the imposter syndrome, that you're coming, say, to a class, and you think, everybody here, because they're like super smart, they got elected to Weizmann, and only me, they don't know. I just, in the interview, I was smiling like really nicely, and therefore they said, you know what, why don't we take them as well? That's like the story that we often tell ourselves. But as you see, from the number of people that laughed here, that it's not only you, it's like they also think the same thing. So be ready for that. And don't let that stop you from that. It's very difficult to get rid of this syndrome. It's something for life often. But being aware of it and being that other people feel that as well makes it easier usually. Okay, and also it usually gets more accentuated or like feels stronger when I'm asking a question and people are jumping and they had the answer already from the beginning. Well, it depends. Some people on a specific question, they already had the answer. And for other questions, you had the answer or somebody else had the answer. And in any case, you came here for the interaction, not for the answer, for to learn. So if somebody has the answer, actually it's good for you. So don't let the syndrome, play you. You decide, how you want to play the syndrome. Okay, good. So we talked about this as well. Okay, a few things about how the course is going to work. So as I told you, we'll try to make whatever we could do in order for you to be successful. At the same time, I tell you, we have pretty high expectations in terms of the effort that you'll have to do. For every lecture, we'll have like an exercise. The first exercise is already on the website and will be like in a minute and a half. And also the expectation is that you grapple with it and do your best in order to solve it. And you have to send it back to us or load it on the Moodle. Yeah, so everything will also be available. We have the website of the course, but actually most of the things will be on the Moodle, so you can interact with everything there. This lecture, the recording coming tomorrow, will also be on Moodle and on YouTube, etc. Which, by the way, I would say, if because we're recording this, if anybody feels uncomfortable about the fact that they're being recorded, please come and talk with us, and we'll try to solve it for you. You can sit in the back in a way that nobody could see you in any way, not even your whatever it's called, and etc. So let us know. So there are exercises, and you have to do them. You have to hand them in by the time of the next lecture. Okay, so a week from now. Okay, we're meeting always Mondays, 11 to 1 here in the building. But I would say anyone who has special reasons why they can't do it on time, no problem. Just let us know. Like, no worries. It wouldn't affect your grade. Just let us know, especially, all those who are in Miluim, in reserve, or if they're abroad, or for any other reason, if you have children, or we don't ask why, we don't even care why, we care, but it's not about that. Just tell us that you have a problem, no problem, we'll find how to solve it. Okay? But you are expected every week to do the exercise for next week. It's part of the whole learning process. Again, this is a way for you to have a horse in the race, and for you to not only see me performing here, but also you performing every week. Okay? We expect you to be in class, unless you can't be in class. And that's also fine, just write us. But why am I expecting you to be in class as part of the course? I hope that you got it by now. Like, it's like you'll be active in the class, and that's part of the learning process. If you can't be in class, you write us. What we expect of you is to watch the recording and send us to the email one thing that you've learned from the lecture and one thing you would suggest to improve in the lecture or in my jokes or something like that. Okay, so that's like part of also your active learning in the lecture. So we had expectations, attention, grading. So if you want to get the grade, that's fine, you'll get the grade. The way it's based is, on the one hand, it's a combination of you handing in the exercises and doing them seriously. And in the end of the course, we'll talk more about it in the end, each one of you will be replacing me for like 5 minutes. You'll be suggesting a question that you think is interesting, and it could be all over the place. It doesn't even have to be just on biology and sustainability. It could be something else. And you'll experience how to try and derive something and show how you do something to answer that question with numbers. I know it sounds intimidating. We'll have time to think about it together. Okay? And to help you with that. So you have to do this, and you'll have to write a short vignette. What is a short vignette? It's like a few pages, like 2 pages, 4 pages, few pages long write-up, where what you did, you introduce the question, kind of like, why is it interesting? And then you do the calculation and give it some context. Okay, so it's also an experience in like writing, if you want, like a tiny paper, but like it's called a vignette. And it's also in the spirit of what you'll see a lot. So the course that you're just hearing is, together with Professor Rob Phillips at Caltech, I wrote a book called Cell Biology by the Numbers. And it's based of, the book is written like based on like 90 different questions. For example, how many proteins are in a cell, or another question I'll tell you in a minute. And then answering it. So you'll see from also what you'll do in the exercises, you'll see examples of such vignettes, which is what you're expected to write at the end of the course. And then we'll do some merge of, your exercises together with this thing that you'll do on the, like a micro lecture and the vignette, and from that you'll get a good grade. Okay? I apologize from the beginning. We're limited in, what would be the, we can't give everybody 100, even if you all worked really hard. But we'll appreciate it and we'll try to give good grading. Yes?
Can we pair up for these assignments?
Yeah, so the question is whether you can pair up for the assignments. The answer is yes and no. I suggest that you first try to grapple with it yourself, to try to handle it yourself, just because in the end, you only have, your brain, and you'll be yourself, in the rest of your life for, maybe you get married during this course, but in general, you have your own challenge by yourself. And then it's completely fine with me, after you tried something, to also talk with somebody else and compare notes and work. That's fine. But in that order. Okay, and in the end, each one should hand their own thing. More questions about that? Okay, for any questions that you have throughout, feel free to email me, the course website, talk with Lior, and talk with Sam, that you'll get to meet soon as well. And now, the final question for today. What is bigger? Or if you like, heavier? Because as we saw, some people have better intuition for this, better intuition for that. mRNA or the protein it codes for. So, I saw that you're very into it, so let's do it. In terms of the options, so it could either be the mRNA, B, the protein, or it could be roughly the same, or it could be It depends. Question is clear? Okay, let's do one last vote for today. Who's voting for the mRNA? About 10. Who's voting for the protein? About 10. Who's voting for roughly the same? 1. Who's voting for it depends? 2, 3, few. Who's voting for it depends? Few. Okay, so first of all, it seems like half of the people are lost. And it's also, I think, a very general observation that people feel a bit less sure about themselves. Like if the first question, you have people who are raising hand like this, now they're raising hand like this. And it's okay. Actually, it's also maybe sometimes it's good because like knowing that you don't know everything is also a useful thing to do. So it's good to come to things a bit more modestly. So I'm happy about that. So in the next lecture, we'll dig more deeply into the subject of sizes in the living world and also other things. And then we'll revisit this and other questions. Before that, there's something else that I think will be nice for you to hear. So we're finishing here, but before that, we have an interesting announcement from an excellent participant in the last year course.
I could have pitched you this course, but no. My name is Dror, I'm doing a PhD in computational biology. I came to pitch you not this course, amazing course, but the debate club, the Weizmann Debate Club. The debate is a game in which we get a subject, which can be anything from pop culture, economy, international relationship, moral question, and we try to find and build analytic arguments that either support this subject or explain why oppose it, why the argument isn't correct. So we can talk about using ChatGPT in classroom. We can talk about should we ban Pokemon from being captured? Do we support I don't know, Taylor Swift redoing all of her albums again? Everything can be a subject, and the game here is not to be super charismatic or super persuasive, but to actually be able to think fast and build your argument in a way that doesn't have lots of logical gaps. So we are trying to build those arguments and to find those missing links in the other people's argument. So we meet every Monday for a lesson with an amazing coach called Miriam, a world top debater, and then we do debates between one another. If you are competitive, there are competitions that we do with other universities or abroad. Last year we flew to Vienna and Amsterdam and Bulgaria. 2 weeks from now we are flying to Vietnam for the World Championship. And it's a great way to meet other people from other labs, other faculties. We are doing the debate both in English and in Hebrew, so if you want to improve your English and prepare for the final lecture, it's also an amazing way to do it. And really improve your analytical skill, your fast thinking. So that's it. We are having an opening event next Monday at 6 at Paramount. With food, which is always a good thing to have. And the coach is going to explain about the club. We're going to do a show debate, so for you guys to see how debates look like. And we are going to have Gil, which is an Israeli world champion. He won 4 years ago. He's going to do a talk about how can we decide between conflict values that we have. So I would very much like to see you there in the opening event. There are posters just outside the class in the board that you can scan the QR so that we can know that you are planning to arrive and have enough food and drinks. And there are an event in Facebook that you can sign in. And if you have a question, I will be after that outside. Hope to see everyone there.
So again, the key numbers, when and where?
Monday. Next Monday, 6 p.m. Food and drinks on us.
Monday, 6 p.m. next Monday. And where?
No, Schmidt, sorry. Next to Paramount. Remove this. Schmidt.
Schmidt next Monday, 6 p.m.
Yes.
Okay. It's, by the way, it's good to remember, like we have different modalities of understanding. One is like talking, and the other is like, reading, and the best is like, together. And also we have to know that like you can't, so there's all sorts of things about it. תודה.
That's it.
One last point that I was reminded when he was talking, when we were talking about like why course today, etc., and somebody was mentioning, I don't know, something with ChatGPT, because somehow it's being mentioned a lot. I would say that like one thing that occurred to me since last course and until now is that what I hope that you also get from the course is the ability, which I think is becoming so much more important today, is to be able to tell bullshit when it's bullshit. Okay? And it's very difficult to do today when you have like, anybody could say something and things like ChatGPT could make it sound like really nice. Okay? But the kind of things that we'll be doing, I'm not aware, even I don't think in the next few iterations of ChatGPT, that it's an ability to understand things more deeply, using numbers to make inferences, comparisons, etc. And I think this is becoming even more important today. תודה. See you next week.